In today's note, we're going to be looking at the certain types of atoms. So we're going to take a closer look at neutral atoms, and we're going to learn about ions. So the types of atoms, there are two types of atoms. There are various types, as I just mentioned. The first type that we're going to look at is a neutral atom. And a neutral atom has the same number of protons and electrons. So this means that these atoms have no charge. So having the same number of protons and electrons means that the positive and negative charges cancel each other out, and you get the result of no charge. And this is basically what we've looked at so far. So if you think of the Bohr-Rutherford diagrams that we've drawn previously for each element or each atom, those are representing neutral atoms because the number of protons and the number of electrons equal each other. The other type is called an ion. And an ion is any atom where the number of protons is different from the number of electrons. So this is something that is going to be new. And these atoms have a charge. Because the number of protons is different from the number of electrons, we could have a result of either a positive charge or a negative charge, depending if we have more protons than electrons or less protons than electrons. So as we just mentioned, there are going to be two types of ions. The first type is called a cation, or the cation is also known as a positive ion. So basically an ion that has more protons or positive charges than electrons or negative charges. So we have more protons, more positive charges. Overall, the atom will be a positive ion. The other would be an anion or a negative ion. An anion or an anion is an ion that has more electrons than protons. So you have more negative charges than positive charges. So the overall atom will have a negative charge or be a negative ion. So those are the two types of ions that you can have. For a cation, you can kind of remember it as cat, and an ion with a positive charge. You could also think of it, cats are good, which is positive, so cation. Onions are bad, they make you cry, which is negative. So like an anion, onion. Yeah. So forming ions. There are a couple things that we want to focus on when we talk about forming ions. The first one is a stable octet rule. And the stable octet rule means that atoms will gain or lose electrons in order to have a full outermost or valence shell. So that means atoms will try to lose or gain electrons in order to get 8 electrons in their outermost shell, hence the word stable octet rule. This basically makes that outermost shell stable. By having the 8 electrons in that outermost shell, it makes it stable, which is what the ion prefers. The other rule is considered the stable duet rule, and the stable duet rule is very similar, except atoms will gain or lose electrons to have a full outer shell or valence shell of 2 electrons. So this differs slightly because there are certain elements that aren't going to try to get 8 electrons. They're going to try to get 2 electrons in their outermost shell. So this only applies to certain ones such as hydrogen, helium, lithium, and in some cases boron as well, where they, based on the number of electrons they have, they don't have enough to try to go for 8, so it's easier for them to go for 2 electrons in their outermost shell. So looking at metal atoms versus metal ions, here we have a magnesium atom. We have our 12 electrons around our positive core. We want to think about what would our magnesium ion look like. So an ion is going to have a positive or negative charge. So we have to think about what our magnesium atom would do. Looking at the outermost shell, we can see that there are 2 electrons in the outermost shell. So we want to get that to a stable number of 8. We're not going to try to get it down to 2 because that would only works for certain elements that don't that are stuck in between that first and second shell. We're in our third shell, so we're not trying to get down to 2. We want to have 8. Now, a hint would be looking at those 2 electrons. thinking of common sense in terms of amount of energy required, you could think in just general terms. It's easier to take away 2 electrons instead of adding 6 electrons. If I take away 2 electrons, if I take away these 2 electrons here, and I get rid of them, that's easier than trying to bring in 8 electrons and try to fill in these spots here, just in terms of energy required to do that. So it's easier to take away the 2 electrons here. So that leaves me that stable shell underneath that has 8. So it's easier to take away 2 instead of adding 6. So that forms our magnesium ion that looks something like this. So we can see those 2 outer valence electrons are now gone. I still have that stable outer shell of 8, which is the one shell that was below. And now I do have brackets around it, and I have a charge because this magnesium ion is slightly different. Because remember, the magnesium ion is the 12th element, so there are 12 protons in the core or in the nucleus, which overpower the 10 electrons in its shells, which means it has a charge of +2. Or you can think of it as we got rid of 2 negative charges. So if I go from negative, or if I go from 0 and I take away 2 negatives, if I'm at 0 and I take away 2 negative charges, or the electrons, that leaves me with a +2 charge overall. So that's our metal ion. So in general, the rule for metal ions, or metals in general, is that metals lose electrons. And when they lose electrons, they're going to end up with a positive charge that is equal to the group number. Remember, the group number is the columns. So magnesium was in the second column, so it has a charge of +2. So some examples of metals in general that would lose electrons: lithium, sodium, beryllium, magnesium. Those are the electrons, or those are the atoms or elements that would lose electrons, and it would result in a positive charge, or positively charged atom, which would be a cation, or the positive ion. Looking at a nonmetal atom versus a nonmetal ion. So here we have a phosphorus atom. We want to think about, okay, what would happen to this atom when we turn it into an ion? So if we look at the outermost shell, we can see that there are 5 electrons in the outermost shell. So we have to think, is it easier to get rid of all of these electrons and then have that stable 8 below it? Or would it be easier to throw in or try to add 3 electrons to that outer shell? Right? So that's kind of the hint, or the thing to think about in this case. So in this case, similar in just terms of common sense, similar to the last example, it's going to be easier for the phosphorus atom to gain 3 electrons instead of trying to lose 5 electrons. If you're just thinking of terms, again, of just common sense or energy, it's easier to gain 3 things than try to lose 5. So that means this phosphorus atom is going to gain 3 electrons. So the resulting ion would look something like this. So here we have a phosphorus charge, or phosphorus ion. Because we added 3 electrons, you could think of that 0 charge. You can think of that 0 charge. We add 3 negative charges or electrons, and we get an overall charge of -3. Because again, those 3 extra electrons are overpowering what positive charges there are in the nucleus. There aren't enough positive charges to help to cancel out those 3 extra electrons, so it leaves us with a resulting charge of -3. So the general rule for nonmetals is that nonmetals gain electrons and have a negative charge that is equal to 18 minus the group number. So for example, looking at the last one, again, phosphorus is in group 15. We do 18 minus 15, that's 3. So therefore, phosphorus has a charge of -3. You could also think of it as, if we're remembering back to the Bohr diagrams, phosphorus in group 15 has a charge, or has 5 electrons in its outermost shell, which means that it needs to gain 3. By gaining 3 negative charges, we would have an overall charge of -3. But in general, all nonmetals gain electrons to have a negative charge, so nonmetals form anions. And some other examples are fluorine, oxygen, and nitrogen. There are a few anomalies or few exceptions to the two kind of rules that we just stated, or the two scenarios. First being noble gases in group 18, they already have a full outer shell. So we talked about this when we talked about the chemical families. Noble gases are unreactive because they already have a full outer shell, so they don't need to gain or lose any electrons. This also means that they have no charge, because the number of electrons equals the number of protons, and they're not going to gain or lose any. Hydrogen is an anomaly because it is a nonmetal, but generally it forms a positive ion. So this means that it gets rid of its one electron to form a positive ion or a cation. So it is the exception to the rule of nonmetals gaining electrons. Hydrogen is more likely to lose electrons. All right, so let's just practice drawing the following ions and write the charge. So I'm going to give you a couple elements, and the goal is to try to draw these, what the ions would look like. So aluminum, potassium, and sulfur. So let's write down here, we have aluminum, we have potassium, and we have sulfur. So aluminum is the 13th element, so that means it has 13 electrons, so 2, there's 10, so there's 13. So realistically, it'd be more beneficial, or we have to think, well, is it easier for aluminum to gain electrons or lose electrons to have a full outer shell? And looking at this, it's easier for aluminum to get rid of these 3 electrons to form or to have a stable outer shell. So it's easier for these electrons to be lost to form the ion. You can also think that aluminum is a metal, and metals again tend to lose electrons. So it's easier for aluminum to lose these 3 electrons. So aluminum has now lost those 3 electrons. So this is my Bohr-Rutherford diagram for the aluminum ion. We just have to add in our brackets around, and because it lost 3 electrons, that means it has a charge of 3 plus, or plus 3, because it lost 3 negative charges, so there are 3 extra protons. Potassium is the 19th, so it has 19 electrons. So there's 2, 10, 18, and finally in its last shell there is 1. So again, looking at potassium, we have to think, okay, is potassium going to gain 7 electrons or get rid of that 1? So generally speaking, and again, looking at the periodic table, we should see that potassium is a metal. So that means it is generally going to be easier to get rid of this 1 electron. And again, you can think of common sense. Is it easier to get rid of 1 or gain 7? It's easier to get rid of that 1 electron. So potassium is going to lose that 1 electron, so there's no more outer shell. So this is what the potassium ion would look like. But again, to identify that it is an ion for potassium, I'm going to draw our brackets around it and write the charge. So because we lost 1 electron, that means that we have a charge of positive 1. So just going back, we can say we have Al, we lost 3 electrons, which yielded aluminum 3+. We had potassium, it lost 1 electron, so that yields potassium with a charge of +1 or 1+. Now sulfur, so same idea. Sulfur is the 16th. Oops, one too many. So sulfur is the 16th element. So there's 2, 10 electrons. 16 electrons. So looking at this, we know that sulfur wants to have a stable outer shell. So that means we have to either add 2 electrons to this atom or lose 6 electrons. Again, thinking in terms of common sense, it is easier for sulfur to gain 3 electrons. So 2 electrons are going to be added to form that stable octet rule, or to follow that stable octet rule. So it's going to gain 2 electrons to form an ion, because it's easier to gain 2 than try to lose 6. So it's going to gain these 2 electrons. So this is what the sulfur atom or sulfur ion would look like. We're going to put brackets around it to indicate that it's an ion, and we're going to write its charge. So in this case, sulfur has a charge of -2 or 2 negative, because we've gained 2 electrons, or we've gained 2 negative charges. So sulfur, we added 2 electrons, so that yields the sulfur ion of S2 negative. So those are the Bohr-Rutherford diagrams for these ions. So in terms of writing ions specifically, not drawing the actual diagrams, so when potassium loses an ion, it becomes positive by 1 and should be written something like this. So we already kind of did something like that. Potassium with a 1+, or you can just write it as K with just a positive sign, indicating that because we don't see a number, it means that it's +1. Looking at examples like sulfur, sulfur gains 2 electrons, so it becomes negative by 2 and should be written like the following, S2-, which we've already done. So it's indicating that the sulfur is an ion because it has a charge of 2 negative. So just as a general overview, metals have a positive charge, or metal ions, have a positive charge or cations, and they can be written as something like this. So we have Na+, Mg2+, and so on. These are examples of metal ions or examples of cations. Nonmetals will have a negative charge because it's easier for them to gain electrons, so they will become anions. And examples of that we can see below. All these elements are nonmetals and they have negative charges. Again, keep in mind there are some exceptions to the case, such as hydrogen and the noble gases.